What is up, geometry? Thanks for tuning in for another episode of Math with Mullins. Today we are buckling up and talking about lesson 2.5, proving statements about segments and angles. We are actually going to see some proofs today, and we're also going to prove properties based on their congruence. So let's go ahead and get started. These first ones, you can work with a partner, you can pause it, and then come back and try it and watch it. But what we're going to try to do is, if we know that AC is equal to AB plus AB, then how can we prove that AB is equal to BC? So if you want to, go ahead and take time now to pause the video here. But if you're ready to check, let's go ahead and continue to let it play. So I know these statements have been filled out for me, so what I'm going to do is fill out the reasons as to why they work. So the first statement was my given. AC is equal to AB plus AB. So that means AB should also be matching to BC, right? So thinking about that, AB plus BC is equal to AC. That is the segment addition postulate, POST. Okay. If we know that, then AB plus AB is equal to AB plus BC. For that reason, we are given the transitive property of equality because we're using one conclusion and applying it to another, so that when we get down here of AB equals BC, we now can substitute BC is equal to AB according to my transitive property. So, because right here you see boop, boop, okay? So this is the substitution property of equality, okay? We're going to do a similar exercise here, except now some of our statements are blanked and we're already given. So this first one should be very easy. It says, 6 steps of a proof are shown. Complete the statements that correspond to each reason. So we are given the measure of angle 1 is equal to the measure of angle 3. And you can tell by that because of the arcs that are placed in 1 and 3. So our given statement is going in number 1. The measure of angle 1 is equal to the measure of angle 3. Okay. Next, we have the angle addition postulate, which is postulate 1.4. The measurement of angle EBA includes angle 2 plus angle 3. Cool. The measurement of EBA then could also be measure of angle 2 plus measure of angle 1 because 3 and 1 are equal. That would be including the substitution property of equality. So the next part says the measure of angle EBA could also be blank, and it says we want to use the commutative property of addition. That just means the measure of angle 1, we're just going to flip it around, kind of like the symmetric property, the measure of angle 1 plus the measure of angle 2. So if the measure of angle 1 plus the measure of angle 2 is given, if you look back up here, the angle addition postulate, angle 1 and angle 2 is C, B, D. So that is equal to the measure of angle C, B, D. So to use that transitive property, that means the measurement of angle E, B, A is equal to the measurement of angle C, B, D. Okay? Hopefully, filling in the blanks for these are allowing you to see how proofs work. So it's basically, how do you connect all the dots in here to be able to prove why EBA is equal to CBD? We know that they're equal, but tell me exactly how and what are those steps. So what we're going to do now is we're going to write a 2-column proof for this situation. Given that measurement of angle 1 is equal to the measurement of angle 3, let's try to work down to prove that DBA is equal to EBC. Here we go. The first thing we want to do is maybe make our 2-column of statements and reasons. And we're going to kind of write over our picture here. All right. Statement 1 is always your given. So we know that the measure of angle 1 is equal to the measure of angle 3. And we're going to say the reason is because that's given to us. Number 2, to start proving DBA, we're going to just start with what do we know about DBA. So the measure of angle DBA is equal to angle 2 and angle 3. Measure of angle 2 plus measure angle 3. This is the angle addition. Angle addition. Okay. Statement number 3. Now that I know that, how can we connect DBA to EBC? Well, if we look at EBC, that is the measure of angle 1 plus the measure of angle 2 is equal to the measure of EBC, and that is still the angle addition postulate. Now that we have made that connection, let's start using that substitution property. So the measure of angle DBA can be equal to the measurement of angle 2 and the measurement of angle 1, right? Because 1 and 3 are equal. This is the substitution sub-prop. Okay. Now that we have seen that, we can use the commutative property of addition. So the measurement of angle DBA is equal to the measurement of angle 1 plus the measurement of angle 2. That's our commutative property. Of addition. So after we put all those together, then we can use the transitive property of the measurement of angle DBA is equal to the measurement of angle EBC, and that would be the transitive property of equality. Okay. Here, we're going to continue on and now talk about segments. So it says, given T is the midpoint of SU, prove that X equals 5. So let's start with number 1. T is the midpoint of SU. Well, the reason is because that is given. Now, the rest of these, some of these are filled out, some of them are not. So that just means the next part we're going to kind of read through and then wait till we get to question 4. Statement ST is congruent to TU because that is the definition of the midpoint. If ST is equal to 2U, that is the measurement of, that's the definition of congruent segments. So that means 7x is equal to 3x plus 20. That is where we used our substitution property. So substitution property of equality. Okay, and maybe I should spell out substitution just so you don't think it's subtracting. Then we would do the subtracting property of equality by subtracting 3 from both sides. So you get 4x is equal to 20. And then how we get x is equal to 5 is we use the division property of equality. Okay. Now we're going to get into some theorems, and you've got some spaces to fill out your notes. I'm going to go with this and kind of underline things that you, or highlight. Let's do highlighting. If I can find the highlighter, I think it is up here. That's okay. The highlighting tool is for a later time. All right, the segment congruence is reflexive, symmetric, and transitive. So the reflexive theorem, that means for any segment AB, the segment AB is congruent to AB. Okay, so we're just writing that next to the word reflexive. Symmetric, if segment AB is congruent to CD, then CD is congruent to AB. So a lot of these you're seeing again before from the previous lesson, 2.4. Then transitive, if segment AB is equal to segment CD and CD is equal to EF, then that means segment AB is equal to EF. These are some examples of where you can see them. You do not need to write that down. Okay, so that's 2.1. Next up, we're going to look at theorem 2.2, which is the properties of angle congruence. Reflexive says for any angle A, and the measurement of angle A is congruent to angle A. Symmetric, if angle A is equal to angle B, then angle B is equal to angle A, And then transitive, if angle A is congruent to angle B and angle B is congruent to angle C, then angle A is congruent to angle C. Make sure you have both theorems copied down for 2.1 and 2.2. Pause the video if you need to. When you're ready to go on, click play. All right, naming the property that the statement illustrates. If T is equal to V and V is equal to R, then T is equal to R. That one would be the transitive. And this would be angle congruence theorem 2.2. Angle congruence. Okay. Next one, if JL is equal to YZ, then YZ is equal to JL. That one would be the symmetric. And since this one is the segment congruence, this would be theorem 2.1, segment congruence. Okay. Write a 2-column proof for the symmetric property of segment congruence given that LM is congruent to NP. We want to prove that NP is congruent to LM. So this one should be a fairly short proof. So let's go ahead and set up our 2 columns. All right, so I have my left side of the statements and my right side reasons. So the very first thing is we always write our given. Segment LM is congruent to segment NP, and the reason is because that is our given. So we are trying to prove, can NP equal to LM? Well, LM is equal to NP based on the definition of congruent segments, okay, which then means NP is equal to LM, and that is where we can use the symmetric property of equality. And because of that, we can finalize this proof by saying segment NP is congruent to segment LM based on the definition of congruent segments. Okay? Next up, prove this property of midpoints. If you know that M is the midpoint of AB, prove that AB is 2 times AM and AM is 1/2 AB. So what I did is I went ahead and marked A to M is the same thing as M to B, but we want to be able to prove AB is equal to 2 times AM, and then AM is 1/2 of AB. So again, setting up our 2-column proofs. All right, we always start with our given. So number 1, M is midpoint of AB, okay? And that is because it was given to us. All right, so let's keep going down. If M is the midpoint of AB, that means AM is congruent to MB, okay? And we know that because that is the definition of midpoints. It tells us up here, if you know that M is the midpoint of AB. So that's the definition of midpoint, okay? Then we know that AM equals MB. And again, that is the definition of congruent segments. If that's the case, then we know AM plus MB will be equal to AB. And that one is the segment addition postulate. All right. If AM plus MB is equal to AB using the segment addition postulate, then we know that AM is equal to MB, then that means we also know that AM plus AM is equal to AB. And that would be the distributive, or sorry, not the distributive, the substitution property of equality. Okay. Line 6 then can now be, we have 2 AMs that are equal to AB, and we can use that with either the simplifying expressions. So you could even say simplify expressions, but mainly this is the distributive property. Okay. Since we know that, prove one more thing. We did just prove 2a times am is equal to ab, but now we just need to know am is half of ab. We know that because we can divide both sides by 2 and get ab divided by 2 is equal to am. So am is equal to ab divided by 2 because of the division property of equality. And I know this is a lot of writing, so sometimes it's best to renumber them. So like given is 1, definition of midpoint 2, congruence 3, segment addition postulate 4, substitution 5, simplify and distribute 6, 7, distribute property of equality. Okay. Last little bit, naming the property that each one of these illustrates. Let's go ahead and pause here, take a moment to try it, and when you're done, click play. This first one is the reflexive property, and then the next one is the symmetric property. Okay, looking back at the previous slide, what would be different if you were proving AB is equal to 2 times AB and that MB is 1/2 of AB instead? The only thing different is that we would substitute MB for AM in step 5, because if you look at step 5, that's where you're proving 2 AMs equal to AB. So we would just change MB for that, so you can prove that MB is equal to half of AB. Okay, and there was just the picture of the proof given there. The last little bit of this would be just looking at the content survey summary of all of your proofs. So with this, you just want to make sure that when you're writing a 2-column proof, the given is always the first thing, the proof is always the last thing where you're proving it, and the steps in between are based on facts that you know or conclusions from deductive reasoning. So remember, deductive reasoning are straight facts so that you can always back it up. It's almost like citing evidence when you do an ELA paper, except this is the more math version of it. Okay. Over here, when you're given your reasons, you're always giving a reason for the very last statement. And then these are going to also include any definitions, postulates, or proven theorems that allow you to state what is a corresponding statement going on. That is going to be it for lesson 2.5. Thanks for hanging in there for our proofs examples, and we'll catch you next time.